All right, welcome to this video where I'm going to go through standard deviation, the equation that we use for it, and then how we can use it to find standard deviation by hand. We're going to take a look and go through that process and then come up with an answer to a question. So, first of all, standard deviation can be used to compare consistency of a data set. If we take a look at a whole bunch of numbers, we want to figure out, is this a very consistent set of data or is it a very inconsistent form of data? And standard deviation can help us with that. So a low standard deviation, small number, okay, represents a more consistent data set. Here's our equation that we're going to use, okay? Our equation, okay, sigma, which is that first little thing there, okay, so let's put that up on the screen first, represents our standard deviation. Okay, so that is a little Greek symbol sigma. It represents standard deviation. We're going to use that for these standard deviation questions. Then, if we work inside, we all know what the root or the square root symbol is, so I'm not going to go through that. But inside there, you'll see this little kind of funny E-looking shape, and that E-looking shape represents the sum. So what we do is we take all the data points behind that sum or after that sum, and we're going to add them all together. We use it for mean as well. So we're just going to take everything behind it and we're going to add all those data points together depending on how many data points we might have. X represents each data point. X bar, which comes up next, represents the mean. And then N is going to represent the number of data points that we have. So we need to understand what each of these points is, and let's go through an example of how we can find that. So here's the example that we're going to use. I'm going to take two hockey players, Patrick Laine, Kyle Connor, both drafted by the Winnipeg Jets, and played or are still playing. One of them is still playing a number of years with the Jets. We're going to take a look at their first 12 years, their first 7 years, or 7 of the really good years of goal scoring, and we want to figure out what is the standard deviation for that data set. Specifically, I'm going to take a look at Patrick Laine's this time, and then Kyle Connor's. I'm not going to do the example now. It's something that I would do later on in my class, okay? But I would do it a little bit differently. So I'm just going to look specifically at Patrick Laine's right now. To find the standard deviation of Patrick Laine's goals, first thing we need to know is what is the mean. And so here's our mean, 28.29, which means he had an average of 28.29 goals over the course of these 7 years. And then you'll see we have our standard deviation formula there on the right. So what we need to do first is take a look at that summation piece there inside the square root. Summation means that we are adding all of those data points together. And what those data points are is the data point minus the mean squared. We have to do that for every single data point, which is why you see that chart there on the left-hand side. Okay, right down there. Ooh, there we go. Yep, just down there. And so in that chart, we're going to do the difference. Okay, that's that first part in brackets. And then I'm going to square each piece. So let's look at each data point. The first one there, he had 36 goals 1 year. So we're going to do 36 minus the mean, or 28.29, which gives us 7.71. So that's that in the brackets. X minus X bar. X, or our data point, minus the mean. Now we square that value, 7.71 squared gives us 59.4441, and then probably some more decimals after that. Actually, no, maybe not. That might be the end of it, actually. Okay, so we have that number then. Now, here's the part where standard deviation can get really repetitive. We have to keep on doing this over and over and over again. So let's do it with 44. 44 minus 28.29 equals 15.71, and then we square that to get 246.8041. Do it again now with 30. 30 minus 28.29, and then 28, and 12, and 26, and 22. And we need to do it for every single data point, which, if we have a large data set, is going to take a really, really, really long time. Okay? Smaller data sets, a little bit easier. So here now we have done each data point. We figured out what X minus X bar squared is for every single data point. So what do we need to do with that? Take the sum of all those. Add them all together. Grab a calculator, add these all together, and you're going to get a total of 619.4287. There we go. Okay, it's added all together. I did it quickly for you. That way you didn't have to do it with a calculator. All right, now take that value, and that's going to get plugged back into the numerator, or the top piece, inside the square root. There it is. 619.4287. I've added in the n as well. There's 7 data points, so n represents 7. And so now I have a calculation that I can do inside of that square root. 619.4287 divided by, well, 7 minus 1 is 6. So we divide it by 6. We're going to get 103.24. Okay, so now it's just a calculation we need to do. And the square root of that is 10.16, which means that Patrick Laine had a standard deviation of 10.16. Now, what does that mean? Well, his standard deviation is 10.16. Yay, we got it. It doesn't really tell us a whole lot unless we start comparing. So this example was going through how do we come up with standard deviation. If we really want to use it, we need somebody else's standard deviation to compare to see who was more consistent. Okay, that's what we need to do, and it's going to come up with some value for it as well. I hope this video has helped you to learn how to find standard deviation by hand. If you need any more help, feel free to ask. Would gladly reach out, and I'll try to help you as much as I possibly could. Thank you for watching. Have a wonderful rest of the day.